Hello all, this is Ankha with another procedural audio tutorial. In this tutorial I will show you how to make a vibrating string sound using the Karplus strung technique. This technique uses a delay with feedback to create the string sound. Starting on the left hand side, we have some signal sources. A noise generator, a sine wave generator, and a sawtooth generator, called a phaser. These are sent to the oscillator level patch, where I can control the level of the noise or the other signal sources. From the oscillator level patch, the signal sources are sent to the envelope generator that triggers a 10 millisecond burst of sound into the feedback patch whenever I click one of these MIDI notes. You will see the trigger indicator turn red every time I click a MIDI note number. The feedback patch sends the signal to the delay right, which records the signal into memory and also sends the signal to the filter. The filter is a resonant low-pass filter. You will hear what this does later. From the filter, it sends the signal to the audio output. On the right-hand side are some message boxes with MIDI notes. The C major scale for 2 octaves. These MIDI notes are sent to the MIDI receive object, which firstly creates a trigger for the envelope generator, and secondly converts the MIDI notes into frequencies. The equation calculates the period of the frequency, which becomes our delay time in milliseconds, and is then sent to our delay read patch, which reads the signal from memory at the set delay time. The output of our delay read patch is then sent to the feedback patch, which controls the amount of feedback that will be sent back to the delay right, creating a feedback loop. Also on the right side of the patch are 2 arrays. Array 2 shows the source waveforms, and array 5 shows the final output waveform. Let's fire up the patch and see and hear what sounds can be created using just noise, oscillators, or both. I will firstly use just noise for my signal source. Watch array 2 for the signal source waveform, and array 5 for the final output. I will now use the phaser as the signal source. Take a listen to how this sounds in comparison to the noise. Of course, we can also combine the noise with a phaser. You can see the noise added to the phaser in array 2. Now let's hear how a sine wave sounds compared to the phaser. Take a look at the waveform in array 2. As you can hear, the sine wave gives a much rounder sound than the phaser. Let's add a bit of noise to the sine wave. By using our filter, we can alter the sound even more. Take a listen. As you can hear, this technique can produce some great sounding string bass. Procedural audio is the future of audio engineering. It not only can create virtually any sound from basic functions, but also unlocks the most awesome power in your PC. Procedural audio is ideally suited for the sound designer, media producer, and electronic musician. If you'd like to see more videos on procedural audio, then go to my website.